Welcome to Defenders, the teaching class of Dr. William Lane Craig. Today, The Existence of God, Part 7. For more information and resources, go to reasonablefaith.org.
Well, we've been talking about the Kalam Cosmological argument for God's existence, and last week we looked at the first premise of that argument, that everything that begins to exist has a cause. And I gave 3 reasons as to why I thought this premise is more plausible than its opposite. Is there any further discussion about that before we begin to plunge into the more controversial and complicated second premise? Yes, there's a question right over here.
Bill, unless I missed it, did you ever explain what the word kalam means?
Perhaps I didn't, Hilbert. In that case, I'll be happy to do so.
I found a number of etymologies, and I wasn't sure which one was right.
It's an Arabic word, and it literally means word or speech. And during the Middle Ages, during the high tide of Islamic theology, kalam came to have a more extended meaning, to mean any statement or position of doctrine. And the whole movement of medieval Islamic theology came to be called kalam. And this is still used today. When I was in Turkey this spring, speaking at the University of Ankara, I spoke at the Department of Kalam. These were practitioners of kalam, to which I was speaking on the Incarnation. So it was just a wonderful experience. And one of the gentlemen, after I finished, he said, "You are a better practitioner of kalam than most of our philosophers." So that was really an encouragement to me. And the reason I call the argument the Kalam Cosmological argument is because, although it has its roots in Christian theology, when Islam conquered North Africa, it absorbed the Christian theological traditions that existed in places like Alexandria in Egypt. And this argument was taken up into medieval Islam and then highly developed, so that some of the most sophisticated forms of this argument were on the part of these Muslim medieval theologians. And so I think for that reason the honorific title, the Kalam Cosmological argument, is well deserved. The argument, however, also was defended by Jewish medieval theologians who rubbed shoulders with the Muslim theologians in Spain while Spain was under Muslim control. And through the Jewish theologians, then this was in turn mediated back to the Latin-speaking Christian European West, where people like St. Bonaventure adopted this argument and defended it, so that the argument has a broad intersectarian appeal, having been propounded by Jews, Muslims, Christians, both Protestant and Catholic. Started with the Christians in their attempts to refute the Greek doctrine of the eternity of matter and the eternity of the universe. These early Christians wrote works against Aristotle, and then when, as I say, Islam supervened over North Africa, they absorbed this tradition, and since Muslims also believe in creation out of nothing, they found these arguments congenial. And it's a nice bridge-building argument for sharing your faith with a Muslim, I must say, because you're on common ground here. The Muslims just love it when I come and talk about this argument, but I usually then will try to transition to talking about Christ as well. Yes, Iraj has a comment here.
Kalam is also, on daily use, is referred to the scripture, to the Quran.
Oh,
so
really?
Muslims, whenever they refer to Kalam, every Muslim knows that Kalam means the Quran. So that's also one thing.
In the same way that we call the Bible the Word.
Scripture, yes, exactly.
Okay, very interesting. Thank you. Well, let's go now to that second premise, which is, I think, more controversial, that the universe began to exist. And what I want to do is to present 2 philosophical arguments in support of this premise, and then 2 scientific confirmations. So we have philosophical grounds or metaphysical grounds for believing this premise, and then we have scientific confirmation of those arguments from empirical evidence. So let's talk about the first philosophical argument, which is the argument based upon the impossibility of the existence of an actually infinite number of things. Remember, we took as our point of departure the medieval Muslim theologian Al-Ghazali's statement of the argument. And Al-Ghazali argues that if the universe never began to exist, then there must have been, prior to today, an infinite number of previous events. The series of events just goes back and back and back without beginning, and therefore the number of events that have transpired prior to today is infinite. But, he argues, an actually infinite number of things cannot exist because this will lead to various absurdities. Now, in order to understand Al-Ghazali's argument, it's very important that we grasp a distinction concerning the infinite, namely the difference between an actual infinite and a potential infinite. Let me say something about the potential infinite first, as I think this is the more familiar usage. Al-Ghazali had no problem with the idea that there could be a potentially infinite number of things. What he wants to deny is that there can be an actually infinite number of things. Now, when we say that something is potentially infinite, infinity serves merely as a sort of ideal limit, which never actually exists, but which one can endlessly approach. For example, any finite distance can be subdivided into 1/2, then 1/4, then 1/8, then 1/16, onto infinity. But you'll never arrive at an infinity-f division. This infinity is simply potential. Infinity just serves as the ideal limit which you endlessly approach, but you never actually get there. The symbol for this sort of infinity is the so-called lazy 8 symbol. That signifies the idea of a potential infinite. Now, by contrast with this, an actual infinite is not growing toward a infinity as a limit. Rather, it is infinite. It is a collection having a number of members which is in excess of any natural number. 1, 2, 3, 4, 5, 6. Any finite number you can think of, the number of members in this collection is greater than that. It is complete. There are an actually infinite number of things existing in the collection. And the symbol that is used for this type of infinity in modern mathematics is the Hebrew letter Aleph. Now, Al-Ghazali has no problem with the idea of a potentially infinite number of things because this just means an ideal limit that you just go on and on and on. You never actually get there. But he wants to argue that an actually infinite number of things cannot exist because various absurdities would result. So there couldn't be, say, an actually infinite number of coins, or an actually infinite number of chairs, or an actually infinite number of particles, or something of that sort. And that would mean that if you cannot have an actually infinite number of things, you couldn't have an actually infinite number of events. The number of past events would have to be merely finite. And if the number of past events is finite, well, then the universe cannot be beginningless. Rather, the universe must have begun to exist, which is the second premise of the argument. Now, before we plunge into this any further, let me ask, is there any question about the distinction between a potential infinite and an actual infinite? Do you understand that distinction? Any question about that? Yes, Claire has a question.
Would you call a numbering system then an actual infinite because you could theoretically keep on just counting forever?
Well, this is disputed by philosophers of mathematics. Some mathematicians think that the natural numbers 1, 2, 3, 4, 5 are merely potentially infinite in the sense that you construct the numbers by adding 1, and that could go on potentially infinitely. But other mathematicians say no, the set of all natural numbers just exists. It's just complete. It's there, and therefore there are an actually infinite number of natural numbers. Excuse me?
Like the deficit, he said.
Oh, yeah. So that's a disputed question, Claire. The vast majority of mathematicians would say that there are an actually infinite number of natural numbers. But there is a minority called intuitionists or constructivists who would say, no, it's merely potentially infinite. But the majority view would be that the number of numbers is actually infinite.
Well, what would be another example of actually infinite? Because that's the only one I can think of.
Right. Now, Claire makes a very good point. It's hard to think of any examples in physical reality and nature of anything that's actually infinite. But I think we can imagine, say, that the universe goes on forever, spatially, and that per unit area there's, say, one star. Well, if there's an infinite number of areas, there would be an actually infinite number of stars. It's not like you're adding new stars all the time. You could imagine, if the universe is spatially infinite, that there would be an actually infinite number of stars. Now, there's no evidence that that's the case. In fact, I think the contrary is true. But that would give you at least an idea of what we're talking about when we say an actual infinite. But I certainly agree with you that it will be futile to try to refute this argument by saying to Al-Ghazali, oh, well, look, here's an actual infinite. I think in every case Al-Ghazali will be able to reinterpret that and say, no, that's merely potentially infinite or finite. I think it would be futile to try to refute him by finding a counterexample and saying, here is an example of something that's actually infinite. Yes, and give your name, please.
Hi, my name is Rusty Entrican.
What's the first name?
Rusty.
Rusty, okay.
Rusty. I noticed that you included the phrase by successive addition here. And
well, now that's the second argument.
Oh, that's
Rusty.
the second argument. Okay,
that's the second one. Here in the first one.
I'm jumping ahead here. All right. Well, my question I think is still relevant to what you were discussing, and that's that since this seems to be concerning formed by successive addition, would this not apply to God? Then could we say that God is infinite?
Okay, this is a good question that is often asked. If an actual as it puts here, well, it's put here, I think, in such a way as to stave off that misunderstanding. An actually infinite number of things cannot exist. You see, God, if we think of him as infinite, isn't a collection that is composed of an actually infinite number of things. And so the infinity of God, as that phrase is used by theologians, isn't a mathematical concept. It's not a quantitative concept. If you will, it's a qualitative concept. The infinity of God means that God is, for example, eternal, necessary, morally perfect, omnipotent, omniscient, omnipresent. He has all of these superlative attributes. But the infinity of God is not a quantitative mathematical concept. And so it simply doesn't fall under the case of an actually infinite number of things existing.
Would time be a potential infinite?
This is a really, really good question. Al-Ghazali is going to argue that time is finite in the past because otherwise you would have an actually infinite number of past hours, say, or days or whatever. But what about the future? Is the future actually infinite? Well, this depends upon your theory of time. In this class, we have differentiated two different theories of time, which we've called the A theory and the B theory. And you may remember the A theory is the view that the future doesn't exist in any sense. The future is pure potentiality. It's not as though your supper tonight is sort of existing up ahead out there and you're waiting to get to it somehow. Rather, on the A theory, things come into being and they go out of being. So on the A theory, if the future should go on forever, it would be an example of a purely potential infinite, so that the future would be, or time would be, potentially infinite. From any point in time you pick toward the future, there will only be a finite number of events that have occurred, but you keep adding new events every day or every second or whatever, so that the future is potentially infinite. So that's not problematic. Now, on the B theory, this is the view that everything in time exists. Whether past, present, or future, everything is equally real. Now, if time goes on forever, in the B theory, then you would have an actually infinite future. You would have an actually infinite number of future events and an actually infinite number of past events. So what this argument would require on the B theory is that time would come to an end. That time would have to have a beginning and time would have to have an end. It would be like a yardstick that has a first inch and a 36th or final inch, and that's the end of the yardstick. On the A theory, time can go on forever because it's merely potentially infinite. On the B theory, time couldn't go on forever if this argument is correct. It would have to be finite in the future. Any other comment or question on the differentiation between actual and potential infinite? All right, now it's frequently alleged that this sort of argument has been invalidated by developments in modern mathematics. This was fine for Al-Ghazali's day in the 11th century, but today it's been overtaken by developments in modern math. For example, the use of infinite sets in modern mathematics is commonplace. Things like the set of natural numbers, 0, 1, 2, 3, and so forth, is said to be an infinite set. It has an infinite number of numbers in it. The number of members in the set of natural numbers is not merely potentially infinite. Rather, in modern set theory, the number of members in the set of natural numbers is actually infinite. There's an infinite number of numbers in the set. And many people will say that these developments have undermined Al-Ghazali's argument because now we see that it's perfectly reasonable to talk about an actually infinite number of things. However, I think this objection is misconceived. What these developments merely show is that if you adopt certain axioms and certain rules, then you can talk about actually infinite quantities in a perfectly consistent way without contradicting yourself. And all this accomplishes is showing that you can set up a certain universe of discourse about infinite quantities. And by a universe of discourse, again, I simply mean you can talk about these things in a self-consistent framework. But this does absolutely nothing to show that mathematical entities really exist or that an actually infinite number of things can really exist. If Al-Ghazali is right, this universe of discourse that's employed in set theory and modern mathematics is just a sort of fictional realm. It's like the world of Sherlock Holmes created by Sir Arthur Conan Doyle. In that fictional world, Holmes lives in Baker Street, has a companion named Dr. Watson, and does all sorts of exploits, has a maid named Mrs. Hudson, and so forth. Those are all true in that fictional world created by Conan Doyle, but none of those things actually exists. And similarly, all that the modern mathematics show is that if you set up certain axioms and rules, you can talk about this universe of discourse in a consistent way without contradicting yourselves. But it doesn't show that it's something that exists in reality rather than just something that exists in your mind. Moreover, I think it's worth pointing out that Al-Ghazali's argument is not that the existence of an actually infinite number of things is a logical self-contradiction. He's not claiming that to talk about an actually infinite number of things is somehow self-contradictory. Rather, his argument is that the existence of an actually infinite number of things is really impossible. Now, to give you an analogy, take the statement, something comes into being uncaused out of nothing. Something came into being uncaused out of nothing. There's no logical contradiction in that statement. There's no self-contradiction in saying something came into being uncaused out of nothing. Nevertheless, I think it's plausible to say that that statement is really impossible. It's really impossible for something to come into being uncaused out of nothing, even though there isn't a strict logical contradiction in saying so. So, Al-Ghazali is not claiming that the concept of an actually infinite number of things is a self-contradictory concept. He's arguing simply that it is really impossible for an actually infinite number of things to exist. And we'll see why in a moment. So these modern mathematical developments, I think, far from undermining Al-Ghazali's argument, actually can support it. It can help it by giving us insight into the nature of the actual infinite and helping us to see what it would be like if an actually infinite number of things really could exist. So far from undermining his argument, these modern mathematical developments, I think, actually are quite helpful and give insight into his argument. Now, is there any comment or question about the relationship between these modern developments in set theory and the argument that Al-Ghazali is giving?
This is maybe going back a step, but about the idea of an actual infinite number of things existing, like you gave the example with the stars or something.
Yes.
For it to actually be infinite, would that mean that all the space in the universe had to be taken up by the stars? I mean, you said if the universe were infinite to begin with, and you had infinite area.
Yeah, no, it wouldn't. It wouldn't mean that all the space had to be taken up, because you would just need to have one star for every, say, cubic million miles or something like that. For every cubic million miles, there's one star in it. Well, if you have an infinite number of those cubic volumes, you've got an infinite number of stars. But obviously, there's a lot of empty space, too, because you could put more things in there. So don't think it would be just jam-packed. That's one of the paradoxes of infinity, in fact, is that it doesn't really fill up everything, even though you might have an infinite number of things. Or here's another example. Think of a wall that has an infinite number of bricks in it. The wall just goes off to infinity, and it has an infinite number of bricks in the wall. Does that mean it would fill all of reality? Well, no. You could have another wall going in the other direction that would also have an infinite number of bricks in it, too. And the two walls could kind of come to a doorway, you know, and on the left is one infinite wall, and on the right is another one. And so you would have two infinites there. So it wouldn't fill up everything, okay, even though an infinite volume would be occupied by each wall. Cindy says, of course. All right, any other question on this, the relationship between modern mathematics and this argument? Yes, Jim. Well, that's in dispute. In a sense, this is an argument to try to show that the past is not actually infinite. That the past had a beginning, is finite, and therefore there must be something that brought the universe into being. Now, in terms of future time, think again what I said about the difference between the A and the B theory. Someone like Al-Ghazali, I think we would say, is an A theorist, and so he would think that the time is infinite in the future, but only in the potentially infinite sense, which is unobjectionable. Now, how will Al-Ghazali show the impossibility, the real impossibility of the existence of an actually infinite number of things? Well, it will be by imagining situations in which an actually infinite number of things do exist, and then drawing out the absurd consequences from such a thing. Let me share with you one of my favorite illustrations, which comes from the great German mathematician David Hilbert, who was perhaps the greatest mathematician of the 20th century. And this concerns a thought experiment that Hilbert developed that has been called Hilbert's Hotel. Now, Hilbert first invites us to imagine an ordinary hotel with a finite number of rooms. And let's suppose that all of the rooms are full. There is a guest occupying every room in the hotel. If a new guest shows up at the desk asking for a room, the hotel manager says, "Sorry, all the rooms are full," and the new guest is turned away. But now, Hilbert says, let's imagine instead a hotel with an actually infinite number of rooms. And let's suppose, once again, that all the rooms are full. Now, this needs to be clearly understood. There is not a single vacant room throughout the entire infinite hotel. Every room in the hotel has a flesh and blood person living in it. There is no vacancy. Every room is already occupied. Now, suppose a new visitor or guest shows up at the hotel asking for a room. No problem, says the manager. And he moves the person who was in room 1 into room 2. He moves the person who was in room 2 into room 3. He moves the person who was in room 3 into room 4, and so on out to infinity. And as a result of these transpositions, room 1 now becomes vacant, and the new guest is easily accommodated. And yet, before he arrived, all the rooms were full. Now, Hilbert says, let's press this a little further. Suppose an infinite number of new guests show up at the desk asking for a room. No problem, says the proprietor. And he moves the guest who was in room 1 into room 2. He takes the guest who was in room 2 and moves him into room 4. He takes the guest in room 3 and puts him in room 6. Takes the guest in room 4 and puts him in room 8. He moves every person into the room number double his own. 1 into 2, 2 into 4, 3 into 6, 4 into 8, and so on out to infinity. Now, since any natural number multiplied by 2 or doubled is always an even numbered, all of the guests wind up in even numbered rooms. As a result, all of the odd numbered rooms now become vacant, and the infinity of new guests is easily accommodated. And yet, before they arrived, all the rooms were already occupied. In fact, the proprietor could do this an infinite number of times and always be able to accommodate more guests by these sort of transpositions. And yet, each time, the hotel is already full. As one student remarked to me upon hearing this in class, he said, if Hilbert's hotel could exist, it would have to have a sign posted outside, no vacancy, guests welcome. But Hilbert's hotel is even stranger than the great German mathematician made it out to be. For ask yourself this question, which occurred to me as I thought about Hilbert's hotel. What would happen if some of the guests start to check out? What would happen then? Suppose all of the guests in all of the odd-numbered rooms checked out, 1, 3, 5, and so on out to infinity. In this case, an infinite number of people has left the hotel. Indeed, as many people have left the hotel as still remain in the hotel, in the even-numbered rooms. And yet, according to the mathematicians, there are no fewer people in the hotel. The same number of people is still in the hotel, namely just an infinite number. Now, suppose the manager doesn't like having a half-empty hotel. It looks bad for business having half the rooms vacant. No problem. By moving the guests in the reverse order that he did before, 2 into 1, 4 into 2, 6 into 3, etc., he turns his half-empty hotel into a hotel that is completely booked and every room is full, bursting to the seams. Now, you might think that by these maneuvers, the manager could keep this strange hotel always fully occupied so that he would never have empty rooms. But in fact, you'd be wrong. For suppose instead this is what happens. Suppose the guests in rooms 4, 5, 6, 7, 8, and so on out to infinity check out. In that case, the hotel will be virtually emptied. There will be only 3 guests left in the hotel in rooms 1, 2, and 3. The guest register will be reduced to but 3 names. The infinite will have been converted to finitude. And yet, in this case, exactly the same number of people has left the hotel as when all of the odd-numbered guests checked out. So, could such a hotel really exist? I don't think so. It seems to me Hilbert's hotel is absurd. And since nothing hangs on the illustration involving a hotel, you could substitute any sort of physical reality for it. I think the argument could be generalized to show that the existence of an actually infinite number of things is absurd. Now, is there any comprehension type question about Hilbert's hotel before we look at critical responses to it might look. Any comprehension type question about what I've said? Yes, Claire?
Well, it seems like you have to keep adding more people at the end when you do this. I don't quite get it, because...
Well, I know that's what it seems. We think of the hotel as being like a potential infinite, don't we? That what happens when he moves these people from 1 into 2, 2 into 3, 4 into 6, that sort of somewhere out there at infinity, somebody's, falling off the edge, or there's a new room being created, but that's not it. Well, see, that would be like a potential infinite, right? But in an actual infinite, I mean, it's unimaginable, but in an actual infinite, those rooms just go on forever. There is no end room. They're all occupied. Every room in the hotel is full. And yet, just by moving people around, you can magically create more space or fill up space just by moving people from room to room.
I must be missing something, because if you're saying in the beginning, I said, I must be missing something, because if you say in the beginning the thing is totally full out to infinity, then that means there's nothing left that's open.
Yeah, that's right, Claire. That's right. You're not missing something. You're just seeing the very, very paradoxical nature of the actual infinite that Hilbert meant you to see by developing this illustration. He wants you to feel uncomfortable with this illustration. And the person who just sort of blows it off, I think, hasn't really thought about it in the way you have. That there isn't any more room for people. Where do these people go? Well, they just go into the rooms that we've said, and just by moving them around, somehow it works out. The question is, could such a thing really exist?
So I think his argument's kind of fallacious then.
Excuse me?
It seems like his argument is kind of fallacious then. It doesn't make too much sense. It seems like it contradicts itself.
Well, no, it's not contradictory. Now, that's what I wanted to emphasize. There's no logical contradiction here, except with regard to the subtraction business, where I said you subtract the people when they check out. As I'll say in a minute, I think there you do really get a real logical contradiction. But at least on the other ones, I think what it suggests is that it's just metaphysically or really impossible for this to happen. But there isn't any sort of self-contradiction, at least in the first part of the story as Hilbert tells it. Okay, let's go to someone else. James?
I have to say I'm confused in general with the examples you're using, because you used an example about space to refer to time. I mean, space has to do with volume. Time has nothing to do with volume, so... what's the relationship there? I don't understand.
Well, I guess it would just be that things in time or in space can be counted. And therefore we can talk reasonably about, for example, how many U.S. presidents have existed or held office. We can talk about what day of the month it is or how old you are. All of those involve counting things which are things that have existed in time. Or we can count how many chairs there are in this room, how many particles there are in the universe, things of that sort. So it seems to me that whether things exist in time or in space, the key here is that these things can be enumerated, and that therefore we can talk about there being an actually infinite number of them. Has there been, for example, an actually infinite number of past U.S. presidents? Well, no, obviously not. It's merely a finite number. Yes, Cindy.
Then are we saying that that space is a actual infinity?
Well, if Al-Ghazali is right, space is not actually infinite. He would say that space is finite.
So there is a limit to the outer boundaries of space.
Well, there is either a limit. Now, here, this is delicate question here, Cindy. Either there would be a limit, or what modern cosmologists will say is that the shape of space is such that it's finite but doesn't have a boundary. Exactly. You know exactly what I'm saying. Yeah. So you think of the surface of the Earth. The surface of the Earth is finite, but there's no boundary. If you start at this point and go off in this direction, eventually you'll come back to the starting point again. And physicists would say that it's perfectly plausible to say that our three-dimensional space is finite but unbounded. So there isn't a limit, but it's not infinite. It's finite, just like the surface of a sphere.
Yeah, I'm not sure if anybody else is on the same page as me, but some of my questions are starting to feel a bit incoherent. With that as a preface, mathematically, to be able to take a number, an infinite set of anything, cut it in half, or multiply it by 2 and get the same number seems to imply something to do with creating and destroying matter. Does that make any sense, or am I just way out in left field?
Well, now, in the example that we gave from Hilbert, there's no creating of new matter, because we just imagine that there is a hotel that already has an infinite number of people in it, and there's a crowd of people outside the door waiting to get in, and there's an infinite number of people in the crowd. And what Hilbert shows is how the manager can accommodate that infinite crowd into his hotel, even though the hotel is already fully occupied. So it's not a matter of creating new matter in this story, at least. All right? Now, sometimes students or laymen will react to Hilbert's hotel by saying these absurdities result because the concept of infinity is beyond us, and we don't understand the nature of infinity. We can't grasp it, and that's why we get these absurdities. But that reaction is just, quite frankly, naive and mistaken. As I said a moment ago, infinite set theory is a highly developed and well understood branch of modern mathematics. And these paradoxes result not because we don't understand the infinite, they result because we do understand the nature of the actual infinite. Hilbert was a very smart guy, and he knew how to illustrate very well the bizarre nature of an actually infinite number of things. So don't think that these absurdities result from a lack of understanding. Quite the contrary. As I say, modern mathematics can give us insight into the nature of the actual infinite so that we understand how these sorts of things would result. Really, the only thing that the critic of the argument can say at this point is to just bite the bullet and just say, well, Hilbert's hotel is not absurd after all. I guess you can have a hotel that is fully occupied with an actually infinite number of rooms that can always occupy more people. And sometimes critics will try to justify this move by saying, if an actual infinite could exist, if an actual infinite number of things could exist, then these sorts of situations are exactly what you ought to expect. If an actual infinite number of things could exist, then you should expect that it will be like this. But I think that justification is inadequate. Of course Hilbert would agree that if an actual infinite number of things could exist, then you could have a hotel such as he had described. The hotel wouldn't be a good illustration if that weren't the case. In order to be a good illustration, it has to be the case that if an actual infinite number of things could exist, then this is what would happen. This is what it would look like. So that's not the question. The question is such a hotel really possible? And moreover, the critics can't simply bite the bullet when it comes to the guests checking out of the hotel, because here you really do have, I think, a logical contradiction. Namely, you subtract identical quantities from identical quantities, and you get self-contradictory answers. In the one case, infinity minus infinity is infinity. In the other case, infinity minus infinity is 3. This is the case when you subtract all the odd numbers from all the natural numbers and you get the even numbers left. This is when you subtract all of the numbers 4 and greater from the natural numbers, then you get 3 left over. In fact, you can get any answer from 0 to infinity for infinity minus infinity. And that's why these operations are prohibited in mathematics, because they lead to self-contradictions. You subtract identical quantities from identical quantities, and you get non-identical answers. And therefore, you do have a bona fide contradiction here. Now, in mathematics, you can slap the hand of the mathematician who tries to perform subtraction with infinite quantities. But you can't stop people from checking out of a real hotel if they want to. If you bar the door, they'll jump out the windows. Well, we're talking about real people in real hotels. And there you cannot simply say, well, that's against the rules. You can't do that, or a contradiction will result. So it seems to me in that case you do have a genuine contradiction as a result. So it's not enough simply to say that this hotel is not impossible because if an actual infinite could exist, then this is what we ought to expect. Any comment to that response? As I say, that really is the only response that a critic can give, and yet I think it falls short. Yes, this gentleman here.
But isn't it a fact that infinity is not a member of the set of all natural numbers?
That's correct. That's a very good point. Nor is it a successor to that set. The series of natural numbers, 0, 1, 2, 3, and so on, don't think of infinity as being sort of like the last member of this series. Or don't think of infinity as in some way connected with it. Rather, if you will, infinity stands outside the series, over and above it, and is the number of members in the series. It is the number of members in the series. And so this is a number. This is a number. This is an infinite number, just as these are finite numbers.
I would say that it is a symbol for the number of members.
Of course, the thing that I've written here on the blackboard...
It's not a number itself. That's the important thing, isn't it?
Well, you're making a correct distinction, but it's the distinction between a number and a numeral. What I have written here on the board is a numeral. That's a symbol. This is a numeral. And you can have different numerals. For example, Roman numerals, 1, 2, 3. Those are different numerals. But their numerals are symbols for the same number. So when I say infinity is a number, I'm talking about the quantity. That's a number. It's the number of members in the series. But the use of aleph, that's just a symbol. That's a numeral. So you're quite right about that. But as I say, the question is, do numbers and things like that really exist? Well, I don't think so. It seems to me they're just fictions. They're just...
Concepts.
Concepts, if you will. And that, therefore, Al-Ghazali's argument, I think, is a good one, that there are no actually infinite quantities of things existing in reality. Okay, well, with that, we'll close, and then next time we'll make the application to the past.
The copyright for the content of this recording is held by Dr. William Lane Craig. For more, go to reasonablefaith.org.